Alrighty. Hello. Alrighty. What's going on, everybody? Okay. What's going on, everyone? Hope you're having a good day today. My name's Michael. Welcome back into the stream today. Today marks, I guess, the first video here of us building our own HTTP server with code crafters. I'm excited to start and do this one. I wanted to the shell one was a really long project, so I wanted to start doing one that was a little bit shorter, so we can maybe wrap up a project sooner rather than later. And yeah, I wanted to keep going practicing with our C programming and see if we could write our own HTTP server in C. So we'll see how this goes. We'll give it our best shot. So thanks so much for being here and hanging out with me today. Thank you, thank you. Let's go ahead and get started today. This is episode 1. I'm contemplating whether or not to put the rest of the episodes behind the channel membership, because the first episode usually does pretty well, but all the other episodes usually fall off. So I don't really know. We'll see. I'm not going to record these. I'm just going to leave them up to the stream, and should be enough. Anyways, let's go ahead and get started. Let's go ahead and get into C here. Say we're a beginner. Okay. Let's clone the repository here. Okay, and then we're going to test our connection here. Should be good. Nice. Nice. Cool. Let's go ahead and open up that file then. Let's get into this. Repos. Okay. Come on. Alrighty. Alright, let's go ahead and get into this one. And yeah, it should be a fun one. Alright, let's see what we can do here. Alright, HTTP server communicates over... Okay, here we go. Bind to a port. This is our task here. Welcome in, everyone. leave a like. Join Code Crafters using my link and pinned comment and in the description if you would like. It's free. Feel free to join Code Crafters. All right, bind to a port. Your task. HTTP servers communicate over TCP, the protocol that powers most web traffic. In this stage, you'll implement a TCP server that listens on port 4221, just like a real HTTP server. How to pass this stage. Uncomment code in source/main.c. Alright. Uncomment the relevant code. Okay, so we're just going to uncomment to pass the first stage here. Okay, so what do we have here? Int server fd client adder length, socket adder in, client adder. fd server fd equals to a socket, call of af inet, sock stream 0. This is socket failed. Reuse is 1. Set sock opt. Some checks for errors. Okay, let's try this. We should be able to just submit this one and move forward. Alright, cool. Move forward. What's up, software? Hey, Lane. Okay. Cool. In this stage, your server will respond to an HTTP request with a 200 response. HTTP response. An HTTP response is made up of 3 parts, each separated by a CRLF, a \r\n. 1 is a status line, 2, 0 or more headers, each ending with CRLF, 3, optional response body. In this stage, your server's response will only contain a status line. Here's the response your server must send. HTTP:/1.1 space 200 space OK with the CRLF. Here's a breakdown of the response. Status line, HTTP:/1.1 version, status code, optional phrase, and phrase. Okay. Client connected. So what happens if we run this program? Then this doesn't, so, So we're stuck on this waiting to connect. It's hot in here. Okay. Let's see what we can do. So our goal here is to respond with a 200 response. So we're not connecting to anything. So maybe we have to provide args. No, we're not giving argv, argc. Request headers, responses. Responses are the HTTP message a server sends back in reply. The response lets the client know what the outcome of the request was. Here's an example. So then how do we connect your tester will then send an HTTP GET request to your server. So client adder length server a cast stock adder client adder. Oh my gosh, I'm like tired already. Just started. It's hot though, that's for sure. I need to turn on the air. It's really warm. Okay, so you can ignore the contents of the request. We'll cover parsing requests later stages. This challenge uses HTTP 1.1. Write code to pass the stage. Head over to your editor ID implement. We're going to be looking at code examples. Okay, so you should send a response with the send function. So let's go back to, let's do man send. System call manual, send from socket.h, size t, send socket, the void buffer, the length of flags, send message, send to, are used to transmit a message to another socket. Send may be used only when the socket is in a connected state, while send to and send message may be used at any time. The address of the target is given by a destination address with the destination length, specifying its size. The length of the message is given by length. If the message is too long to pass automatically through the underlying protocol, the size EMSG size, eMessage size is returned. Okay, so we connect to the client. I guess, do we send? So if we look up the send page, send has what in it? The socket we want to send a message to, void buffer, I guess is the message, the size of the message, and the flag. So I guess we'll say send to okay, so what do we have here? We have client address, sock address in, which comes from the struct, sock adder in. It's a type, which is client address. So we have client address. So I guess we send to the client address, right, a message, which will be success. An HTTP response made by sending messages. Okay, so we need to create what do you send? Let's go back to those examples. Oh, you physically send that whole string. Okay, so you would say HTTP / 1.1 200 OK /r /n, which is the CRLF, that, right? Okay, so what if we do, we can't take the size of, we'd have to do char star success is message is equal to this, or a success response, right? This is a response. Right? And then we would do success response sterling success response, and then we would give what, 200 here for the value. Okay, so if we open up a new thing, cd into source, or we'll do code crafters submit. Okay, let's see here. Let's go back into a new folder, cd into source. We'll go gcc-o .c. Error passing in sock adder type incompatible to int. Okay, so let's go back here. This is int socket. So we need an integer. I guess which is client adder, which is server FD. Maybe it's server FD. Let's go back to that example. You can test this step by running the application and from the command line test. Okay, so let's do okay, so let's do we need to fix that thing first. So let's find what those examples really quickly. Just takes client. Where is client? Client address line, client adder. We don't just have a client. It's gotta be to server FD, no? Um, libraries. Okay, so we can't, this won't compile. Right, so we're passing struct sock adder in, which is client address, into a int type socket. So this is the socket, I guess, that we're wanting to connect to, which is the client address. So this is a struct though. So client address. So sock adder in. The sock address in is the client address. Socket. Okay, let's go. Okay, so the socket function creates an endpoint of communication, takes in a domain, type, and a protocol. So in this one, we took in AFINET, which is our domain. Type is sock stream. Protocol is 0. It creates an endpoint for communication. Domain and parameter specifies communication. Domain will take place to select the protocol family. They're defined in socket.h. They're in these formats. So INET, Internet version 4 protocols. We did AF INET. Indicated type, sock stream. A sock stream type provides sequenced, reliable, two-way connection based byte streams. An out-of-band data transmission mechanism may be supported. A sock dgram. Protocol specifies a particular protocol to be used in the socket. Normally, a single protocol exists. Okay, so we Send a response. We send a response. I don't know. What would be the... HTTP version, status code, optional reason, phrase, headers, response body empty. So this is not right here. We need something else to go, an integer. Only a connection backlog, which I don't think is it. Reuse, no. It's gotta be server FD, but I don't think that that's it either. And we can send a... Maybe we have to have it running. Waiting for a client to connect. Okay, so it is running, I think, actually. So then if we open up a terminal and we run client connected. Okay, so we've connected to our server here. Okay, so this terminal is connected to this terminal, this server. Rec CV failure, connection reset by peer, client connected, and then it dropped. So I think it's because it just closes the server. So to send a response then, where do we send this response? We would send it to the client address. Maybe we would do, let's look up on man pages, man send to. Send to is the socket. So all of these take in the socket we want to send. Socket address, destination address. So maybe it's this we want to send to. But what? But can I just use the client's address? But that's a length. I don't want to use the address of client address. I want an integer. Client address dot address. Dot client. I don't know what is the. No, no member named client. Do I have a header file here for I can inspect and then open network tab, reload the page. I'm not connecting to localhost yet. So if I run the program. But the thing is we don't have source. So this, I'm trying to figure out what socket are we trying to send this message to. It's an integer, right? And the only integers we have are this backlog. We have this sock adder in, which is our server address, which has port sign address. Oh, here we go. So we have a member. Maybe it's port here. Because it's supposed to be a what? A socket. So let's do underscore sign or dot sign underscore port for our client adder dot sign port. Let's run this. Okay, so we got back did we get back a successful 200 response here? What's going on? Hey, Slow. Hey, John. How's it going? Imperium, what's going on? Okay, so the struct has this port, but I don't think that that works. Let's run again. Well, this is running automatically. So I don't think it's I don't think it's sending anything. It's connecting and it's not doing anything. 8 a.m. red hair. Nice, dude. Nice. I got that. It's for me. It's 6:39 p.m. Okay, so let's look up response message client in C. Make the following addition. So I thought that, so the client, okay, so in this line, what is the client? That's what I don't get, is we have client address. Would it be south on a portion that's going out? would it be S out port? Let's try it. No S out port in the struct. Server import. Maybe that's not an integer. I don't want to look it up. I'm trying to get this. Let's see if it's like even failing code crafters here. No content received. So we're not sending back anything to the client here. We have client address length given the client adder. But the client adder is a struct of sock adder in. I mean, do I int cast client adder? I don't think so. Why would you cast a struct? Oh! What do you guys think? We were trying to send a response, and we just need to figure out what. So this is the response here, so maybe this is 0 here, right? Because the response is taken out of this. So let's look up client socket. Should int cast to C. Okay, where is C? What is C? Where is C? Where is C? Oh, you take in C. Okay, so let's int cast it, I guess. I don't have a good feeling about this, but find out. No. No, so how, what he's casting a input here, right? Yeah, it's pretty vague in terms of, it doesn't really give us a lot of an HTTP response is made up of 3 parts, each of a replace. So I don't know what to put here. What is our client's socket? Set socket option. socket is socket. So server FD. Server FD is an integer. What's the function signature of send? It's a socket, it's an int. So send has socket. The address of the target is given by the destination address. The address of the target is given by the dest data with dest length specifying its size. Where's the rest of my thing? What's wrong with this? So cast s in underscore port to an int. Okay, maybe we'll try that. So client adder dot s in port and cast to an int. It's worth a shot here. We'll try it together. Okay, I'm going to take this line here. Let's get some help on this. Function for valid socket file descriptor. Client FD. We have server FD. We don't have client FD. So client adder. Struct sock adder in. So again, what if we say, is there a client? Client address dot so could you show me the options in the struct? That'd be really nice. It's in, what is it in? Socket.h. Dang it. Okay, so client adder dot I don't know why I'm not getting autocomplete here. Is there autocomplete for structs? That's probably why. Let's get this extension here so we can get access to some of the options in the struct automatically. Oh, there we go. Oh, why'd I do that? Localhost, what are we connecting to? 411? 4221. Network. Okay, so all right, that helps a lot. Holy crap, we were doing this. We've been writing in C this whole time, just raw, no syntax highlighting, no nothing. Oh my gosh, I thought that that's just how it was. Okay, that makes it a lot better. So client adder dot sign address, sock in address, sock in family, sock in length, sock in port. It's gotta be port. Like, right? What is the input here? We don't have a client FD. Well, hold on, I think we gotta compile first. No. Oh my gosh. Alright, bro's getting banned for that one. I think you can make it. Yeah, they have control click on the send function. Command click, sorry. Int. Yeah, it's int. Socket.h. Do they have the server FD client address struct sock adder star? So struct sock address pointer to this address. So where is the client server or the client? We get a socket of server creation failed. So we create a socket. Find server address. So you're binding the server address into the server and listen. Okay, but then you wait for connection here. Oh, there. So then you have client address right here, which is what we were using, which is struct. But this takes size of client address. That's weird. How can you take the size of client address when it's a struct and save it in length? So it takes in a socket as an integer. Um, the client file descriptor is returned by the accept function. Okay, so maybe that's what we're missing. Okay, so accept returns an int. The call returns -1 on error, and the global variable error number is set to indicate the number. If it succeeds, it returns a non-negative integer that's a descriptor for the accepted socket. Okay. So we say int client is equal to this. And then we put the client here. Is that really all it was you had to realize the accept returns? Who was that said that? Kinetic? Okay, let's see. I didn't know that returns something. At least, okay, now we know. Oh my gosh. Okay, so let's try it now. Ooh. That looked better than before. Status failed. Error. Oh, we got it. Okay. Let's go ahead and submit this up. Oh! Yo, Kinetic Squared. Shout out you, dude. Holy crap. That was that was rough. That was step 1. We've been sitting here for 52 minutes. Oh my god, dude. Okay, so that's so dumb. The accept function will return back the client, and then you can send a response to said client. Ugh, that's so annoying. Interesting. The size of a struct just returns the size of all of its members. A struct with an int and a char would start would have 8 bytes because an int and a char would each 8 bytes. We're learning HTTP right now, Seth. Okay. Cool. I thought I did. I thought I already installed this. Oh, is it like an extension? Oh, it's the extension pack. The extension pack. Okay. Okay. Boom! Mark is complete. Yeah, I was looking at that software. I was like, what? I don't think it's 8. I think it'd be that plus the int and the char star. It should be 8 plus 8, right? Okay. Cool. Extract URL path. In this stage, your server will extract the URL path from an HTTP request. Okay, so we have a request, and we want to extract the path and respond with either a 200 or a 404 depending on the path. An HTTP request is made up of 3 parts, each separated by a CRLF. The request line, 0 or more headers, each ending with a CLRF, and an optional request body. Here's an example. The request target specifies a URL path for this request. Note that each header ends in a CRLF, and the entire header section also ends in a CRLF. What's wrong with this request? But you'll learn about parsing headers in a later stage. In this stage, the request target is written as a URL path. But the request target actually has 4 possible formats. The URL path format is called the origin form, and it's the most commonly used format. The other formats use more niche scenarios, like sending a request through a proxy. Okay, so in this stage, your server will extract the URL path from an HTTP request and respond with either 400 or 404 or 200, depending on the path. Okay. So we get connected, and then we will send we will send what? Okay, so we need to, an HTTP request is made up of 3 parts. The request line, the 0 or more headers, optional request body. So the request line is this, headers is this. So what's this gonna send? This is gonna send some random string to look for the response of that server response. Okay. So we need to we have a hey, what's going on, Supreme Lord? How's it going? Okay, so I'm kind of stuck. These are tough. Okay, so we need to accept a request to the server. So our client, we accept a request here, and it gives back our client. And so we got a successful connection. Client is connected here. So we say we need some sort of conditional here for we'll do this 1.1404. We'll write our response that's bad, right? Okay. That's our failure response. And so we need to have a conditional, right? So if client send this response, else so we'll send the failure response. Maybe like that. So it will determine if the client was successful in this call. Right, so now let's go here. So it looks like it's able to connect still beside this. Um, So why? So the client will always come through. Um, so failure response to the client. Well, you'll always have a client, right? So we don't want to say if client. We want to extract out some sort of data, right? But so the request target is what we're wanting to extract. So we would need to, this returns back the client. And then they're gonna send something. My suggestion is to use the curl to send custom HTTP requests and debug locally. Okay, so let's see. Oh shoot. So we got HTTP 200 no matter what. And then it resets by peer. So this will print the response that we're sending, but we need to conditionally check to see if it's there. HTTP requests lack an explicit end file marker. Okay, so we have this will give us a sock stream, right? So server FD is an integer. Anybody have any ideas? So what kind of, how, we need to extract the path, but how can we extract the path if we accept Huh. Ugh, I suck. I just don't know see that well in order to do this. So like we need to extract out this path past the get. So where is this request target at? In our response, our client structure. So if client adder dot accept fill out the struct members. Yeah, it probably does fill out the structure members. So do we do the address? Expression must have arithmetic or pointer type. So if client adder, so slow, you think it would be in the client adder struct. So this is struct in adder. Internet address, a structure for historical reasons. So this will just huh. This is troll, man. I suck. I'm sorry. The request target. So let's just look up where yeah, how do you access the request body data? The request target is found in the request line of the request message positioned. like parsing the first line of the incoming socket data, typically using a function like stir token or stir chr to isolate text between the first space. So then, where is the stream? Where's the stream been found? In the socket buffer. So, operating system accessed in C via the client socket file script returned by the accept function. In a C server, the HTTP system, the request stream is not a file or a distinct object, but a sequence of bytes arriving over a TCP connection. You access this stream using the receive v system call or read on the specific client descriptor. Okay, so interesting. Okay, so let's go back here. So let's look up man read. What? Okay, so if we go read, takes in an integer. Okay, so you would use this rec v. What the hell? Receive a message from a socket. Receive. Rec v. Rec v. Function is normally used only in a connection socket. Okay, so we're going to use rec v. Rec v. Right, we're going to receive the client. Right? We're going to have a buffer of data. So char star buffer, I guess, of 1024. Um, $10.24. So we would receive from the client, we'd save into the buffer array of characters. It's not a buffer, it's a buffer array of characters, not a buffer pointers. Sorry. You would do the size of, right, the buffer to make sure it doesn't go over it, less than 1, so we can save a null terminator with 0, so as something here. Okay. So this is going to be called we accept the client we would now we need to that is the title of the stream, my friend. Okay, so we'd have the buffer here, receive from the client into the buffer. We would need to do stir token. Let's quit here. Stir token. This interface is obsolete by stir separator 3. The stir token function is used to isolate sequential tokens in a null terminated string. These tokens are separated in the string by at least one of the characters in sep. The first time that the stir token is called, the stir should be specified. Subsequent calls wishing to obtain further tokens from the string should pass a null pointer instead. What? These tokens are... Subsequent calls wishing to obtain further tokens from the same string should pass a null pointer instead. The separator string sep must be supplied each time image call. Huh. Okay, so thanks, dude. Thanks for coming in, TGG. Appreciate you. We're trying our best here, but not really getting that far. Okay, so we need to tokenize. So we receive into buffer the string that our thing is giving, right? So we would get a token. So we'd stir tokenize the buffer, and we would give it a separator of a space, right? Does this return a value? What does this do? The stir token functions return a pointer to the beginning of the subsequent token in the string after replace the token itself with a null character. Okay, so we would... Do you call this twice? Returns a pointer. I'm going to try this. it's a string. Okay, so now if we connect to it, get, okay. So then if we do it again, but you pass in a null, you pass buffer again? Get. How do you pass a void pointer like it said? These tokens are separated in the string by at least one of the characters in SEP. The first time that the stir token is called, stir will be specified. Subsequent calls wishing to obtain further tokens from the same string should be passed a null pointer instead. The Codecrafter site doesn't tell you how to access the byte stream. No, it's pretty vague on it. It's really kind of leaving it up to us here. You're doing great. This is hard. Thanks, TDG. Would you put it in a while loop and then do something like pointer to token? Okay, so feel free to make a free Codecrafters account with the link in the description or pinned in the comments. It's free. It is a referral. It helps me out. I got you guys a discount code if you wanted a discount through that link if you want to upgrade. I figured that a lot of us are, people are struggling, college CS majors and stuff. So yeah, I figured that we could get a link for everybody. Okay, so the stir to let's take this. I've never used this function before. How to get more than one token. To get more than one token, you pass null. Oh, it's just null. Get the first token. If ch is not equal to null, method is equal to ch. Okay, so we can, got you. Interesting. So we'll just loop. I mean, we could build a structure if we wanted to and hold everything, but it's whatever. So let's just do this. Char, or we say while ch, or char star ch is not equal to null, \0. While char star ch not equal. So that one just, they're not looping, okay. They're just calling it repeatedly. So if we had stir to token, this gets our, right, so this is, we'll say this is our request type. We'll spell it out. So our request type is here. We then call char star to path is equal to stir token given null and delimiter. Right, so what else does the path look like? The version. So maybe we should tokenize. Okay, let's do this. Let's do this first. So we receive the stream into the buffer. And then what we're going to do is we're going to tokenize. So char star, this is the request line, is equal to stir to token, right? And we're going to save initially onto buffer. Right? The request line, save onto buffer, and we're going to look for the lines \r \n. Okay, we're going to split on this a literal \r and a literal \n, right? That'll give us the request line. We have char star okay, that's fine. So then we just need to so I guess we would have to I guess we just need a pointer to the start of this thing, so it'd be after the get. So this receives into buffer. This takes buffer, goes through it, and looks for the first occurrence of this, and then saves that into request line, a pointer to the start of the first one. Okay, then we have request type, which will go through request line, right? And then we have path, but the stir token, like, the thing is we're changing the buffer, right? So that's my question. Is this quote backslash? Oh, it's not the literals, it's looking for these markings. Okay. So a return in a new line. Oh, got you. Return new line. Okay, yeah, so it does. Okay, got you. So we have the request line. We stir token the request line, but then we get path So if I print path here, I don't think that that'll work though. Treat the string as an argument to avoid this. Oh, whoops, sorry. Slash. Let's just print. I thought printf will go until we find the first null terminated string. Well, it's path pointer to. I thought printf. Let's put S here. Slash. Okay, so we're working as strings. But we want to look for the first instance of space, right? I'm guessing you're working through the buffer, which is first in, first out. If the string is a variable. That's what I thought. That's what I was doing. Path. Char star is a string from path. Okay, I'm going to take this. I'm going to see. I'm going to get some questions on this. Can I swap the buffer mid stir talk? No, you cannot swap the order. This scans buffer and replaces a first string get with path and path with this. The first call replaces the first space between well, this runs first. Request line. Oh, we have to null terminate it. So receive v doesn't null terminate. I was assuming that it did because of this, but we need to do this ourselves. So buffer at index, what size of buffer? Well, no, it would be. But what would you do to null terminate? Size of bytes. Oh, so receive v returns you back the number of bytes read. Okay, so the number of bytes read from the stream is saved into bytes returned. Okay, so this would be a lot easier if I just was better at these functions. Like, honestly, so it's just a lot of it's honestly like I'm trying to use a package that I've never or library, honestly, that you never used before. That's what it kind of feels like. Okay, so buffer at index of bytes, the last, we will set that equal to the null terminator, right? So we will, now that gets set, we go through the request line and split it, right? Yeah, request line. So this does, okay. So you do a check if you get request line back. So if request line, you open this. Okay, so if request line, then we will get the type, request path, and this is going to be what, host, version here. So let's print all three of these and see what we get. I'm trying to learn here, you guys, so sorry if this is not the fastest or the most, if you're like, do it! We've been reading through C Programming, A Modern Approach live on the stream. We read chapter 17 yesterday. And so we're just trying to get some practice by using code crafters. I have a link in the pinned chat. You can sign up for free, or first link in the description. Sign up for code crafters to get access to building your own HTTP server, building your own shell, building your own a lot of great stuff. So sign up for free using that referral. If you want to upgrade, feel free. No pressure. I do give you a discount through that link, but you can get access to some free stuff on there through that, and feel free. It helps me out with the referrals, so I appreciate it if you guys could just make a free account and mess around with some of the projects. They're fun and they're challenging, right? I am challenged here. I'm challenged for sure. Okay, so let's try this. Let's connect get/http. Okay, so there's nothing there because we're not actually pinging anything. Okay, that makes sense. I was like, why isn't our printf printing the rest of the response or the request path? Well, we're not sending any request path. We're just getting there. So let's send a request path. Let's send a request path now. Oh! Let's go, boys. Hey, what's up, said who? How's it going? Yeah, this is more practicing C library than C language. CPP reference has all the info on these functions. But to be frank, using libraries is what usually you do with C. Your receive v method should be in a loop. You should read from it till the bytes received is 0 or -1. Receive v should be in a loop. That doesn't... Does that not just automatically save all of the bytes into the buffer itself? That's what I thought it did. And receive. The receive function is normally used on a connected socket and is identical to receive from with a null pointer pass as its address argument. As is redundant, it may not be supported in future releases. All three routines. Okay, so receive from calls are used to receive message from a socket, may be used to receive data like whether it is or not connected to oriented. Because it goes up through this length, right? This is the limiting factor of how far it traverses through reading, right? If you don't want to modify the original buffer, you could use str. Stir stir? What the hell? Or stir character. They return a pointer to the first occurrence or null if they don't find anything. Oh, so right now it's modifying the buffer by replacing the new line, new characters, or new return new lines with it, which are the HTTP 1.1 requests, right? Stylings, right? So there's multiple things going on here. Is someone programmers out there have come up with a request like kind of styling like body, right? That you have to like a formatting almost, right? It's kind of like laws or whatever that people have come up like all agreed on, and so it's expecting curl response or whatever or expecting this formatting, and so we're saving this into a buffer, and then at each of these occurrences we're writing a new line character. So if we wanted to reuse our buffer for instance, rather we would either copy or we could use a different function, you're saying. Why would we not want to write over the buffer, Sonia? Every time I hear someone ask me if why I'm not using AI, I give them a 1 minute timeout. Sorry, Muhammad. Yeah, stir talk replaces the character it finds with a null terminator. If the bytes read isn't 0. If the bytes read isn't 0 or -1. I'm sorry, I'm not following. I don't know why I'm not following. So receive will read bytes into the buffer. If each byte. Oh, so will this stop like prematurely if it doesn't come across? What causes this to stop reading is when it comes across, oh, the total size. Okay, got you. So you're saying that. So what if my buffer size runs out and there's more to be read? Is that what you're saying? But you'd have to clear out the buffer each time and read in each section by section. Is that what you're saying? You'd go like, okay, read in the first section into the buffer, parse it out, clear the buffer, keep going in like a loop. Okay. So there's definitely improvements we can make, right? This is just pretty fragile. So what we could do is loop while, right, while the response, the number of bytes is greater than 0, right? You're reading bytes, um, or not -1 or something like that. We have to mess around with the different type conditions. You would read the section into the buffer. But how would you identify how much to put in the original buffer? Right? This just reads to the original size of buffer -1, right? But how would you then understand, okay, what if you're reading and it cuts off like right in the middle here? Like, okay, right? And you try to parse that, it's not going to work that well. Hey, what's up, Mateus? You guys know what I'm trying to say? So how would you be able to know how much to read into the buffer? I get that you're limited by the size here, but how would you stop prematurely? Like, okay, so you would read a chunk, but what if it stops like right in the middle here? Like you want to stop kind of at like a before you read one of these if you don't have enough in the buffer to put it in. You guys know what I'm trying to say? Like for example, let's say this is like a really long request, right? It's really long. You're reading, and let's say you run out of space in the buffer, like right here, right? Then you go to parse that, and so you can then clear the buffer. Well, you can't. You'll pick up. I think that's what I'm confused on. Okay, let's go back here though to what we got going on here. You look for the null terminator. You can't parse it. You have to wait until you have the entire message. Oh, or you've okay, got you. Or if you get failure, then you can. Okay, so you wouldn't parse the message inside the loop. You read all until it's all in buffer. Do you continually extend the size of buffer until right? Let's go back to receive here. If there are no messages available for the socket, the receive call waits for a message to arrive until the socket is not blinking. If no messages are available to be received and thus the peer is performed an orderly shutdown, the value of 0 is returned. The calls return the number of bytes received or -1 if an error occurred. The return value 0 means the peer has closed its half side of the connection. Okay. Okay, that sounds fine. Okay, so if we want, we're going to save null terminate bytes. So we'll focus on reformatting that in a second. But what I'm trying to figure out though is if you can either have a fixed size buffer in global memory or you can dynamically extend it. It's up to you. But for a basic server, you could also heap allocate like 1 MB of buffer for your requests. Okay, so we haven't yet gone over heap allocation of sizing with malloc yet. So should we try it? Should this be our chance? But for right now, I think we can probably complete this task here before we can probably move on here. So we want to, if the path is given, we want to give a successful response, right? So if request line, so if not request line, let's well, if request line, we would do all of these. Okay, so we'll have to, okay, then what we want to do is we have this conditional here. And so if request path, we would open this up and say if request path. Right, so this is in this conditional though. So we might have to say if not request path. If we have not request path, then we need to, since some sort of error there, else do this, or this is request line, sorry. Okay, I guess it's an error, right? I guess we could like printf. And return 1 here. Else we'll go ahead and get these values out of the request line. And then if request path, send client success, else send this close server. Okay. I think we're good to try it out. Come on, boys. Come on, prayers up. Prayers up. No. Madam. Okay, so maybe we didn't compile. Hold up. We gotta compile. I forgot. We always do that. We did that last time where we were trying debugging over and over and over again. It's all because we didn't recompile. Oh, whatever. Okay. Come on, prayers up. Ah! No. Okay, so we're still getting incorrect response here. Well, you would always have a request path here. So if request path equals null, right? I guess you'd have to specify if it actually is null or not, potentially. Let's try that. Let's try that. Be a little bit more specific here. No, I thought we got it. Shoot. Let's see here. Hey, what's up, Danza Jones? I'm here for I don't even know which language yet. Please be C. Yes, this is C. Welcome in, everybody. You guys can subscribe and like. Appreciate you being here. Thanks so much for joining me. Make a free Codecrafters account. Do some of these projects if you're wanting to build live, real cool, implement real computer science, projects. Do it through Codecrafters. Use the free link in the description and in the chat here. It helps me out. Hello, there used to be a stage alien invasion. Okay. Get out of here. Later. Realize you would have a sort of state machine that would probably try to parse it on the fly. If it can't, then it would probably use a sort of dynamic array. Oh, got you. I also think real servers set an arbitrary limit to the HTTP header. You can't parse the header because they reach the limit, then the client part is probably DDoSing you. Oh, there's a lot. Yeah, I need to get better at like HTTP. This is why I wanted to do this project because this is like really. I don't know. Like I feel like the internet is so abstract, and there's so many different things going on behind the scenes that I really want to know more about like these things. I don't know. It just seems so interesting. Okay. So we got 200 this time. So request path is not null. So if request path is equal to a blank string, or just this, right? Because request path has nowhere to go from here. I think that actually might be it, right? Whoever said that gave me a hint. Who said I didn't realize that we got a different status code there. Good on you. Let's see if that works. Okay, hold on. Okay, so hold on. We have to do if stir compare. If stir compare request path and equals to / equals to 0, meaning they're equal, then we'll do this. I forgot that you can't. This ain't Python. This ain't Python. We're not in Python anymore. Oh! You spin my head right, going down, we're going down, down. Woo! We serving it up. All right, sweet. Let's go. Nice. All right, complete. Nice. We're not in Python anymore. We got to use functions to compare strings. Oh, phew. I didn't know if we were going to get that one. That one was tough. Okay. We're learning, though. We are learning a lot more about HTTP requests and responses here. Hot Take C is easier to learn than any front-end framework. Actually, I actually think I'm having a better time learning C than I have learned JavaScript so far. So I think that holds true, Sonia, at least from my experience. JavaScript literally looks like hieroglyphics. I don't know why. Oh my gosh. They like the cluster framework. Yeah, that's funny. Oh, not stir compare. Oh, that's a cool. Okay, so you can write simply not stir compare. Oh, cool. Left operand comma has no effect. Oh, I didn't do stir compare. Okay, that should be. All right. Cool. All right. Okay, let's try this one. Make sure we're good. In this stage, you'll implement the /echo/bracket stir endpoint, which accepts a string and returns it in the response body. A response body is used to return content to the client. This content may be an entire web page, a file, a string, or anything that can be represented with bytes. Your /echo/stir endpoint must return a 200 response with the response body set to given string with a content type and content length header. Here's an example of an echo stir request. Echo ABC blah 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 blah. Here's the response. ABC. The two headers are required for the client to be able to parse the response body. Note that each header ends in a CRLF and the entire header section also ends. Okay. Okay. So we need to. Okay, so what we need to do is detect if our request type, no, if our path begins with echo, right? Okay. Okay, so we have to, our path is what houses this right here. And we need to parse this path and find echo. And then echo what's next. Okay, so we'll open up this if statement. we'll still send the 200 response, right? But you send a response that has all of this stuff built into it. Okay, so we probably want to make a function that'll generate us a content length string and a function that'll generate us maybe a content type string. And then we can just concatenate those to our successful response and send that out. I think that's our plan, right? Anyway, welcome to HTTP Server Game Man. I've been building servers in C++ for over a decade now. Yeah, Jasper, I want to get better at this. So if you got any tips, let me know. Join the Discord link down below and chat with me offline and let me know if you have any tips or resources that'd be good to learn. It just seems like this kind of black box, honestly. And I've been trying to eliminate the black boxes. That's what a lot of computer science feels like. Okay. Okay, if you guys are here, if you guys are new, you guys could please make a CodeCrafters account. It's free. It helps me out with referrals for a free account. Appreciate that. It's a pinned comment and also in the Discord or chat, or first link in the description. We're building a HTTP server with CodeCrafters. Build your own HTTP server. It's a pretty cool site, and it's made by some cool programmers. And I like how it's very like not. It does kind of it just gives you like the bare bones of what you need, but you really have to think. It doesn't do a lot of hand holding, which is really nice because yeah, it's hard and it's difficult and I struggle and I want to quit sometimes, but when I come out the other end, pause, it just really feels good. Pause. Oh my God. Okay. So we have the request path here. So if here, this is a successful right? So a successful path is here. So we're going to say, well, we first need the command, right? So we have to go through this and figure out if there's a command. So we'd have to be like, if, or I guess we could token. Let's do that. Let's call stir toke char star command is equal to stir token, but we have to save into a buffer, no? No, we just need a string, which was originally in a buffer, right? In this case, it is the request path. And we're going to look for the /, right? So that'll give me the start of the command. Now, whether that's the better way to do it, I'm not sure. Right? And then we have char star I mean, maybe we say if command if stir compare command and if these, then we're going to go char star echoed. Stir talk the null for the same current request path, looking for the /. We're then going to, I guess, let's build our string, right? So we'll probably make a function for this and build it that way, but we'll just do it temporarily right here for now. So we know we have a success response. And so what we can do is, what we can do, okay, so we need a sn printf. So, okay, what do we want to do? We're wanting to build our response string, right, which is content type text / plain content length thanks, Jasper. Appreciate you. But defines ones have been released in mode but don't happen in debug mode. Maximum pause awareness. That's funny. Okay, so we want to save and print f, right? So let me open up, I forgot the man sn print f. Okay, so this prints to a file pointer. Char star restricted string size t. We'll write a most size 1 of the characters printed. Size -1 of the characters printed into the output string. Oh, maybe not. Okay, so I'm kind of brain farting here. So we have echoed. This is going to give us the value that we're going to echo. And now we build a string though, content type, right? Text / plain. So this is where we would have to figure out the length. Oh, with Python it's so easy. So how with C can we, I guess what we'll do is stir cat this. We want to do, can you cast a char star from an int? Right, you can do size of echoed index of 1 plus plus echoed. But this returns an integer. You can't just cast a string like that, can you? So what I'm trying to do is build this string by basically using an f string in Python. You guys know what I'm trying to do? We read chapter 1 of that Crimson live on the stream here, but we haven't gone back. Content length is the length of the body, not the header. Well, what's the body? ABC. See, this is what I'm trying to do here. I'm not sure if that's right. I don't know. Well, I guess we could just do echoed less than 1, right? But I don't... But does this save into this string or give you back a new string? Forgot. Return the pointer S1. Okay, so it just returns a pointer to S1, so it looks like it modifies S1. Yeah, this is a get request. And you're just getting this for this echo here. We had S in print, right? F, but this gives me back a pointer. So if we just the value at the pointer, it's just a character. Char. Huh. Oh my god. So it sends it didn't even send the response, I don't think. Maybe it did. We need to dereference the pointer. Oh. Client connected. Dang it. This echo should be a post. So what does it get here? So if strcomp command echo. Oh, because this is giving the first occurrence. Oh. So we'll do stern compare command echo. And the size. We want to do the first 4 characters. Client connected. So you stern compare stir compare. Comparison goes here. So if they're equal to one another for the first 3 strings. I'm going to say command. It's probably a good idea. Print F, debug the command string. Client connected. Okay, this isn't working. Is it sending the response at least still? Not found. Yes. Okay, so I'm confused. So if stir compare request path is not not true. These aren't the same comparison paths. Oh, so this isn't even entering, I don't think. Oh, because it's not a backslash. Oh. Okay, so you would have to, you'd say, just read, you want to stir compare this path here, I don't think. This is the risk failure, which is fine. Because it's not even entering into that because it's not comparing it to equal the backslash like it was. Right? Okay, so because before what was going on is this is comparing request path to just this. So if it's not just that, oh, then you go into this. Okay, so I think it's okay then actually. If it's not equal to this, if the request path and this are not the same, then we enter into this block here, right? And you would say, this would stir talk. You need the command. Let's see, so you have, this is our path here. You get the first instance of the slash. This gives you your command. Okay, so, but this should enter. Why doesn't this enter? Okay, so I can't stir cat this with something. It has to stir cat with an object. Okay. So the thing is we're not even getting into here. Right, we're saying alright, I'm kind of pooped for today, you guys. My brain's slowing down here, I can tell. We streamed for 2 hours and 24 minutes. I already have a full-time job as a biochemist, equipment guy, so I already do that all day. So I appreciate you guys being here and hanging out with me for today. Hate to cut it off. Hate to cut it off here. We got 25 people here, so I hate to cut it off, but I'm pretty tired. I'll be back tomorrow while we'll continue on with our learning in C, and furthermore, we've been doing a lot of reading in C programming and modern approach, building our own shell, writing our own HTTP server, kind of just hopping around different stuff just to have fun and keep it variety. So yeah, I appreciate you guys hanging out with me for tonight. If you guys have any tips, so we're trying to figure out here, when we come across an echo, we need to identify that that is the command given in this request, and then echo out the response, in the response, the content here, ABC. But we need to concatenate the length, right, with a pre-built response string. So that's what I'm trying to figure out, is how can we get the content length 3 to be included into a string. Like Python is really easy with just, oh, stir lang. Stir lang, no, that doesn't work. Well, yes, it does. Content length, string, okay. Oh, that's right, just use stir lang. Okay, so we'll get the length of the string, append that to, but then you have to cast that to a char star, right? All right, cool, guys. I'll see you guys later. Peace out. Thanks for hanging out with me for today. This was super fun. Make sure you like and subscribe. Join Code Crafters. It's the first link in the description and pinned in the chat. It's free. Again, it's free. Code Crafters is a great free version where they rotate the projects monthly. If you want to upgrade, you can upgrade with a discount through me. It helps me out if you do. No pressure though. I do everything here for free anyway, so it's cool. So no pressure. Thanks so much for hanging out with me. And but if you do want to make a free account, it does help. Pre.